We use a variety of instruments to measure different metric measures, like length is measured with a ruler or a meter stick or a speedometer. Which instrument we use will depend on the type of measurement unit. A ruler is usually used to measure shorter lengths and straight sections. A tape measure could measure longer lengths, centimeters and millimeters. Then we have a vernier caliper, which is used to measure the width or the thickness of paper, rather of wood, paper, bolts, anything like that. Then we get micrometers, which are screw gauges. These are only a couple of examples. Speedometer, I'm sure you know a speedometer in a car. That's also measured to measure long lengths of distances. Mass is defined as having an effect on or involving a large amount. It has many other scientific definitions, and we'll refer to it as weight. Instruments that measure weight and/or the mass of an object are weight scales, chemical balances, usually used in laboratories to measure the weight of an actual chemical, measuring jugs that we use on a daily basis in our homes. We get spring scales, normal scales. The unit to measure volume is milliliters or liters. This is generally a liquid. So volumes of liquids such as milk, water, oil can be measured by using various measurements or instruments. And that we had a look at the measuring jug. When you are measuring the volume of a liquid, always place the measuring cylinder on a flat surface. You should move your body toward downwards so that your eye is on the same horizontal line as the surface of the liquid. If you lift the jug, it will cause a meniscus, which is the curve that's caused as soon as you move the jug. When reading the volume of liquid, always read at the right angle of the jug. The unit measure for time is seconds and minutes, and time can be measured using the following instruments: a clock, a watch, or a stopwatch. These are all examples of how we can measure time. Calculating distance, time and speed uses the following triangle. If we take this triangle by default, you have your distance at the top, speed on the bottom left, and time on the right. To be able to calculate and to use these formulas, we take distance divided by speed equals time, and distance divided by time equals speed, and speed times time is equal to the distance. If we know we'll be traveling to Durban at 120 kilometers per hour, and the distance is 600 kilometers, so I have my distance and I have the speed that I'll be traveling at, I just don't have the time. If I wanted to calculate the time, I take the time formula and substitute the values 600 for the distance and speed 120, and that will give me 5 hours. It is important to use the appropriate unit or symbol when measuring length, distance, mass, volume, or any other measurement. The following table outlines the symbols to use and apply when measuring. When performing calculations, it is important to note the unit of measure as well as the end result. Failure to do so renders the result meaningless. Using the correct symbol when reporting measurements is therefore very important. Architects, builders, designers, etc. all rely heavily on the final unit that is used, as important decisions are made based on them. Shapes like triangles, rectangles, circles, pentagons, squares, ellipses or ovals, hexagons are all types of shapes. Now each of those shapes have different sides. A triangle, for instance, has 3 sides. A pentagon has 1, 2, 3, 4, 5 sides. A square is 4. Ellipsis is round, and a circle is perfectly round. The idea here is when they have 2 dimensions that only have a length and a breadth. These shapes that you see on the screen there now, we can only see 2 sides to them, either the length or the breadth. They don't have a depth dimension. Therefore, they are only 2-dimensional. Then we get three-dimension shapes. Do you notice the difference between the ones we just saw before? These actually have an additional dimension where we can see the third side. Hence they're called three dimensions. So a square now is no longer a square anymore. It's now a cube because it has three sides. Then we have a cone. A cone is no longer a triangle. It's now become a cone because it's got three sides and it's also circular in shape. Then we have a cylinder. Can you see a cylinder has got a third dimension? We can actually add volume to it. So we can add liters, any type of liquid into the actual shape. And then we have a pyramid. A pyramid now has four sides. It's also a triangle that's got a second or third dimension rather. Then we have a prism, which is a shape that has got two triangles with a depth of the triangles in between. Now we get right-angled triangles, which are a little different to our same-sided triangles where all the lengths of the triangle are the same. With a right-angled triangle, Pythagoras, which was a very, very old scientist, he came up with the following theorem. He says that for a right-angled triangle, the square of the hypotenuse is equal to the sum of the squares of the other two sides. In other words, the area of the largest square is the sum of the areas of the other two squares, and this is always true. So if we take a look at our triangle, if two items are meeting at right angles, which is at a 90-degree angle, and we join them together, that length or that side is called the hypotenuse, and that is equal to the square of the other two sides. In our example, you'll see there that we have one square's got a side of 4 centimeters, the other one 5 centimeters, and then 3 centimeters. So if we put that into our formula, we have 5 squared equals 4 squared plus 3 squared, and you can go and calculate what that calculates to, and that will give us the length of the hypotenuse. If we take a look at how to calculate the area and a perimeter of a shape or of a space, maybe you're building a house or whatever the case may be, and you want to calculate these ideas or calculate how many tiles you're going to need, all right? So you need to know the area of the specific space, because the area is the amount of space that object would occupy if it was put down on something. All right, so if we look at a square or a rectangle for that matter, the calculation is the same. We look at the formulas as follows. It's the length times the breadth. So we take the breadth multiplied by the length and we get our answer. And then for a triangle, it's a little bit different. We take half the breadth multiplied by the height. So if our breadth, in other words, the breadth, the bottom part, the base of our triangle is 4, so we'll take 2 then in that case. All right, so it's half the breadth times the height. And then for a circle, it becomes a little bit more different. We use a formula there, and we use pi, and we multiply that by the radius squared. And the radius is half of the circumference or half the diameter of the circle. For a perimeter now is if I take those shapes and I open them up to form one long line, that will give me the perimeter. So if I walk around my schoolyard or my office block or wherever I am, I walk around there, that is my perimeter. So in the case of a square or a rectangle, it's 2 times the length plus the breadth. For a triangle, it's the sum of all the sides. So if I took that triangle and I opened it up and I made one long line, what will the length be? So it's the sum of all the sides. And then for a circle, we're looking at 2 pi radius squared. Now, just previously we took a look at calculating the area and the perimeter of a 2-dimensional object. All right, now it won't change for the area and perimeter even if that was a 3-dimensional object. Obviously, you just take then the breadth into consideration. If we were calculating volume, when we calculate volume, this means we want to find out not how much square meters or how much space that item takes up. This we want to know now how much can actually fit inside. All right, so when we're calculating volume, we're looking at how much can actually fit inside. So we can take a prism or a which is a rectangle just with an additional side. So we take then the length times the breadth, and we add that extra dimension times the height as well. All right, if we wanted to calculate the volume for a prism, we would take half the breadth, just like for a triangle. We've taken half the breadth again, times the small height, well, the triangle's height, and times the depth or the height of the actual prism. And then if we're looking for at a cylinder, we see it's pi radius squared times the height. Do you notice here that with the three-dimensional shapes, the only thing that comes with it, and when we're calculating volume of how much that goes inside, then we're only looking at one extra element there, and that is the height of the item or object. Cartesian graphs are another way of measuring specific distances, but in ratio. If you think about maps, if maps were in actual distance, we wouldn't be able to fit the map in this entire world, or the map would be as big as the entire world, because we can't put everything in that same scale, because a kilometer in real life and a kilometer on paper, if I wanted to represent it, we need to make sure that we make a ratio, because it's so different. I can't put papers together to form 1 kilometer. I'll never be able to represent it like that. So we use a Cartesian graph, and a Cartesian graph creates a scale. So it specifies each point uniquely in a plane by a part of numerical coordinates, which are the signed distances from the point to the fixed perpendicular directed lines, measured in the same unit of length. So this will say, and in easy terms, basic terms, we can see there in our graph, if we looked from 1 to 2 and we were now wanting to plot something, or we needed to find out what the distance is going to be to Durban, for instance, we can say, right, Durban is 600 kilometers away. So we can then make 1 kilometer, or we can make 100 kilometers for that matter, 1 on the Cartesian graph. So in that case then 100 kilometers will equal 1. So our ratio will be 1 to 100, 1 to 100, and that is then represented as 1:100, and that is a ratio. Then I would say my distance I would plot at 1, and then I would plot another one at 2, and another one at 3, another one at 4, another one at 5, and another one at 6. And that will tell me that it's 600 when I translate it into the actual distance or the real distance. And that's a wrap for topic 2. Make sure of using the correct instrument and measurement units when measuring. 2-dimensional shapes have only 2 sides, while 3-dimensional shapes have 3 sides. Area is the space an object occupies on the surface. Different shaped objects have different area formulas. Perimeter is the sum of the outside of the object, and Cartesian graphs are graphs used to display measurement in ratios.